Today I'm going to show you what's inside of an engine and how it works to power your car. Now in this video I'm going to start with the overview, the disassembly, and then the individual components. The engine is broken up into 5 main subcomponents. At the top here we have the valve cover, then the cylinder head, and then the combustion chamber or engine block, and then the crankcase at the bottom here, and then the oil pan down below. This here is the front of the engine. We've got the crankshaft here that powers the harmonic balancer, which turns all of the accessory belts on the front of the engine. Inside of the timing cover is where the timing chain is that goes from the crankshaft to the camshaft. So over here at the top of the cylinder head on the intake side of the engine, air goes in here. Out at the back here is the exhaust side of the cylinder head where it goes into the exhaust header. Now over here we've got a couple of inlets and outlets for your cooling that goes to your heater hoses and your radiator hoses. Down at the back of the engine is the crankshaft where it connects to the flywheel before it goes to the torque converter in the transmission. So in the engine block here we've got the coolant that enters here, we've got a water pump over here, and the starter that sits over here. And then of course further down at the bottom we've got your oil filter, your oil pan, and then your crankshaft sensor. So we all know the basics of how an engine works. We've got the cylinder over here and that has a piston inside that moves up and down. When fresh air with gasoline is drawn into the cylinder, we've got a spark plug that ignites it and causes an explosion which pushes the piston down, and that pushes the connecting rod down against the crankshaft, which is at an offset, and that causes a torque on the crankshaft, making it rotate. That rotational motion is transferred to the wheels through the transmission. Now when the piston moves back up, the exhaust fumes move through the valves into the cylinder head and then out the exhaust manifold. Now while the crankcase is the heart of the engine that produces rotational motion, the cylinder head is pretty much the brain of the engine that controls the valves through the valve train. Now in order to disassemble the engine, I'm going to start by removing the timing cover as well as the valve cover. I'm going to first start by removing the crank pulley bolt, and the pulley comes off. Next I'm going to remove the valve cover from the top of the engine. And now with all the bolts removed, I can lift off the cylinder head cover or the valve cover. So here's a look under the valve cover. This is a dual overhead cam engine, which means that there's going to be 2 camshafts that control the valves that go down into the cylinders. Here we've got 4 spark plug holes, and then the timing chain over here for these 2 camshafts. So on this engine, this is the exhaust cam that goes out to the exhaust manifold, and on this side here it controls the intake valves which come in from the intake plenum. So on this engine, the variable valve timing happens on the intake side only. Alright, so with the valve cover removed up at the top here, I'm going to proceed to remove the timing chain cover. Now the timing chain tensioner is located inside of here behind the timing cover. And then I'll remove that. So with all the bolts removed from the timing cover, I can then proceed to remove it from the engine block. So in behind the timing cover here, we've got the crank sprocket which spins the chain. The chain will then spin the intake and the exhaust cams before it goes back over here where it gets tensioned by the tensioner. Next I'm going to remove the timing chain guides. Then I can remove the guide. So just to demonstrate how the timing chain works, you've got the crankshaft here which turns this chain, and that turns the cams at the top. So now with no chain on the tension, I can now go ahead and remove it. So this is how the camshaft rotates. Now underneath these caps here is your journal bearings, and that's the interface between the camshaft and the head itself. That needs to keep well lubricated in order to operate smoothly. Over here is the cam position sensor, and it senses the position of this camshaft according to these tabs on the end of the camshaft on the intake side. The tab moves in front of the sensor and the sensor will pick that up. So next I'm going to remove the camshafts. There's a couple of 12mm bolts over here on the timing side of the engine, as well as all the 10mm bolts that hold the bearing caps on the intake and exhaust side. I'm going to remove these cam bolts. 14mm. This is the variable valve timing gear. And now I can remove the intake camshaft off of the engine head. Now over here on the intake side of the head is the fuel rail. It's held in by these 2 14mm bolts. These green things here are your fuel injectors. And then I can pull this fuel rail off. This here is where the oil control valve is located for the variable valve timing on the intake side. And then I can remove the valve. Now the head of the engine is held in by 12 bolts. These are bi-hexagon 10mm bolts. I'm just going to be using a plain hexagon 10mm socket to take them out. And this is what the head bolt looks like. Alright, so now that all of the head bolts have been removed, I can lift off the head from the cylinder block. And now I can remove the head gasket. So this here is the engine block with the head removed. You can see this is the pistons here. This is a 4-cylinder engine. You can see when I rotate the crankshaft clockwise that the pistons move up and down. You can see the general condition of this engine here. The pistons have a lot of carbon buildup, but the walls of the cylinder are smooth and don't have any major grooves. So now I'm going to rotate the engine upside down so I can work on the bottom. So with the engine turned upside down, I'm going to next remove the oil pan. It's held on by 16 10mm bolts and nuts that go around the circumference. This here is the oil pickup screen and tube. It picks up oil from the sump and it feeds it to the oil pump over here. Now if you look inside of here, you can see how the connecting rods and the pistons move up and down when I turn the engine. This here is the crankshaft. It's pretty much the heart of the engine. Now throughout the middle here we have 5 main bearings that run through the center of the crankshaft. Underneath this bearing cap here is where the connecting rod, which moves up and down with the piston, connects to the crankshaft. And you can see that it's offset from the center line of the crankshaft. The distance between the center line and the connecting rod is called the throw, and that will determine the stroke of the piston. While the engine is running, the oil pump ensures that this entire crankcase assembly is well lubricated in oil. Next I'm going to remove the bolts that hold the main bearing to the crankcase. These are 12mm bolts. I've got a 12-point socket for it there, and I'm going to use it on a breaker bar to break them free. Now I'm going to break free the bolts that hold the bearing cap onto the connecting rods. These are 12-point sockets, 10mm. Now I can remove this bearing cap. So with the connecting rods from the pistons free from the crankshaft, I can just move the crank a little bit and reach down with my brother's toothbrush and push the piston out the bottom of the engine. Oh crap. I got a toothbrush in the engine. And I can catch it just like that. And there's a piston. This here is the oil pump. It's responsible for pressurizing the engine to ensure all of the components are lubricated properly. And then the oil pump. You can see that the crankcase here is a separate piece of the engine block down here. So we're going to have to split this and remove the top part in order to get the crankshaft out. Remove the oil filter. So with the oil filter removed, I need to remove this 12mm hex bolt. Now I can remove the 12mm bolt that was behind the oil filter. Now I can remove the entire crankcase off of the bottom of the cylinder block. So with the crankcase removed, we have a clear view of the crankshaft with the offsetted connecting rod bearings up here, the 5 main bearings over here, as well as the counterweights over here. So what's also interesting are these holes on the bearing surfaces that allow oil to penetrate between the bearing itself, the crankshaft, as well as the engine block assembly. This rubber seal over here is called the rear main seal, and that seals off the crankcase, which holds engine oil from the transmission side of the engine. A lot of times these will leak and cause a leak between the engine and transmission, and it's very expensive to replace because you have to completely remove the engine or the transmission from the vehicle. Now I'm going to remove the crankshaft from the engine block. It's pretty heavy. And here's a look inside of the engine block with the crankshaft removed. Here we have the bearing surfaces where the bearing rides up on. You can see that there's a slot inside of here where oil will come from inside of here to lubricate this bearing. Now sometimes you'll hear the term "you've spun a bearing," and what that means is that if this bearing is starved of oil, it fuses to the crankshaft and that causes it to spin. And once it spins, it leaves a gap on the bottom of the crankshaft, and that causes the engine to knock because of that gap that you left down at the bottom there. This here is the engine block where it mates to the head. We've got a coolant jacket that runs around the cylinders to keep it cool. Now it's very important that this surface is machined really flat, because when the head is bolted on, it has to hold a lot of compression from the combustion that happens in the chamber. Over here we have 3 oil return galleries that will take oil from the head and return it back down to the sump. And this little hole over here supplies the head with oil. Now when they say that your head gasket has blown, that means that this gasket has failed and it's losing compression between cylinders, or it could mean that the coolant is mixing with the oil, and that's bad. You'll also notice that the cylinder walls are actually a steel insert inside of the aluminum block. This is the head of the engine removed. Now the cylinder head here houses the camshafts that control the valve movement throughout the 4-stroke cycle. Now the camshaft has a bunch of these eccentric cam lobes that rotate, and we've got the valves here which are spring-loaded. When the camshaft rotates such that the lobe hits the valve, it will actually squish the spring down, pushing the valve into the cylinder head, and that will allow inlet air to come in or exhaust gases to escape during the cycle. Now in order to link the movement of these valves at the top here with the position of the piston in the 4-stroke cycle, we have a timing chain that goes from the crankshaft to the intake cam and then the exhaust cam. On this particular engine, the intake camshaft is variable, which means that the timing that this valve moves in and out can be controlled by the ECU. We've got 2 exhaust valves and 2 intake valves on this particular engine for a total of 4 valves per cylinder. You can see that when I rotate the intake cam, how the cam lobes will actually push down on the valves opening the valves into the cylinder head. So if you watch the intake valves over here, as I rotate the engine, you can see that they're moving in and out according to the position of the camshaft. So here's a look at the bottom of the head. You can see that all around the cylinders is the coolant jacket where it cools off the head, and then it exits out that side to the radiator. We've also got the oil return ports at the bottom here, as well as the supply port at the top here to lubricate the camshaft. Now in order to remove one of these valves, I'm just going to use my spark plug socket and whack it with a hammer, and that will release the two holding pins. And I've got the valve spring, I've got the retainer at the top here. Now I can just pop out the valve from the bottom here. And the valve here has this groove, which is called a valve seat, where it seals against the engine block. And you've also got an oil seal at the top inside of the cylinder head that seals against oil dripping down into the cylinder. Now if you look closely inside of there, you can see the valve stem seal, and that's used to prevent oil from going from the valve head into the engine. Now each of these valves have a little cap on them where the camshaft will ride up against. Now the camshaft itself is pretty light and hollow, and it's got these holes inside here to help lubricate the bearing surfaces along the camshaft length. Now this camshaft profile is specifically designed in terms of its width, its height, as well as its rotational position relative to the rest of the shaft to control the valve timing, when it will open, how long it will open for, and how deep it will open, as well as when it will open in the combustion cycle. Now in between the intake and exhaust cams you have the spark plugs, and that provides a spark to ignite the fuel mixture in the cylinder. Now when the valve cover is on, you've got this ignition coil that sits on top of the spark plug, and that transfers the 12-volt signal from the computer into many thousands of volts to fire that spark. You can see on the bottom of the head, in the middle of these four valves is where the spark plug is located. Now sometimes these spark plugs will wear down and get carbon buildup on them, and they'll need to be replaced in order to keep a good spark. And this here is the crankshaft. We've got the center that goes around here with the 5 main bearing surfaces, and then we've got the counterweight, which is opposite of the connecting rod of each piston. Now each counterweight here looks like a casted piece, but it actually sounds kind of hollow. Now it's very important for this crankshaft to be extremely balanced because it will produce a lot of torsional vibration from the reciprocating motion of the pistons. Now in a manual transmission car, we usually have a flywheel which has some weight to it that's mounted to the transmission side of the engine. In an automatic car, we've got a torque converter, and that helps to dampen some of that torsional vibration. Now on the belt side of the engine, we have what's known as the harmonic balancer, and that serves as the pulley, and it also helps to dampen some of that torsional vibration. Now on the center bearing, we've got the semicircular thrust bearings. So here we have the piston, and on this side here is where all the explosive action occurs that pushes down the piston. On the side of the piston here we have 2 compression rings, and then we've got an oil expander in between here, followed by 2 oil rings on either side. Then we've got a piston bushing over here that connects the connecting rod. This is a forged piece that goes down to the bearing here at the bottom. So in order to aid with lubrication, we've got a little hole here where oil will come from the crankshaft, and it will lubricate this bearing. Then we'll exit here and go through the top of the connecting rod where it will spray into the piston walls as well as this bushing up here. And now I can tap out the bushing. So now with the bushing removed, I can remove the connecting rod, which is just a forged piece, and the bushing here. Up at the top here we've got the piston rings, we've got 2 compression rings, the oil rings here, and I can remove like this. Sometimes these rings can wear down and cause a loss of compression or for the engine to burn oil, and then you're in for an engine rebuild. Now the purpose of these rings is to seal against the cylinder walls so that the combustion is kept within the combustion chamber, and the oil ring here will whisk off any excess oil so it doesn't go into the combustion chamber and get burnt. This here is the oil pump removed from the engine. We've got the inlet here and the outlet over on this side, and it's driven by the crankshaft of the engine. Now the timing belt cover pretty much seals the front half of the engine. Over here we've got the crank seal, and we've got the crankshaft sensor, and the crankshaft sensor will read off of this little gear here that's spun off by the crankshaft. Over here we have a little hole that will feed oil to the timing chain tensioner. This is the crankcase. It's just a piece of cast aluminum. These are the spots here where the crankshaft will ride up against the main bearings, and you can see that we've got some oil passages that go to the oil filter. This is the oil pressure sensor, and on the bottom here we've got the inlet for the pickup tube where the oil pump will draw oil from the sump. Now modern engines are built with very high tolerances, so in some cases your valves could actually extend into the combustion chamber, and if your timing is off, your piston could come down and clash and hit those valves and bend them. This is called an interference engine. So the next time you start your car, give it a second thought to think about all of the engineering that goes inside of your car's engine. So to get a better idea of what it looks like inside of here, I'm going to chop it open. And there you have it, a chunk off of the engine and what the water jacket looks like around the cylinder.